Okay, for this problem, we're going to do some naming. We're going to take a look at some alkanes. These are all going to be straight chain alkanes, and we're going to go from structures to names. This is quite a bit more challenging than going from names to structures. And so with these, we have to apply all the rules. In other words, we have to use the rules to come up with the name rather than using the name to come up with a structure. All right, so let's count the longest chain. It looks like the longest chain is going to be 1, 2, 3, 4, 5, 6. So we've got 6 as the longest chain. And now what we need to do is we need to number it. I think that if I remember, we number in the direction that gets us to the substituent the fastest. 1, 2, 3, that would be that version. And then 1, 2, 3, it's a tie either way. So it doesn't matter which way we number it. So 1, 2, 3, 4, 5, 6. And the reason it doesn't matter which way we number it is because they're both methyl groups. In the case that they weren't the same substituent, we would pick the substituent that comes first alphabetically. So there is a hierarchy of rules that helps you break ties, but at the end of the day, once there is a tie, it doesn't matter. You can pick either direction. Okay, so it's six carbons long. So that means it's a hexane of some type. And we have some methyl groups. We have 2 of them, so that's a dimethyl. And where are they located? They're located at 3 and 4. So putting it all together, it's 3, 4 dimethyl hexane. Okay, so that's that one. Let's do this one. Looks like the longest chain for this one, that's the first thing we're going to do is find the longest chain, is 1, 2, 3, 4, 5, 6. Not surprising. We're going to see lots of hexanes. So let's number it now. So the numbering would go this way: 1, 2, 3, 4, 5, 6, instead of the other direction because we get to that methyl group the fastest. So it is another dimethyl hexane, but instead of this one, which was 3, 4, this one will be 2, 4 dimethyl hexane. All right. So let's take a look at the next one. Let's find that longest chain. Looks like it's 1, 2, 3, 4, 5, 6. I told you we'd have lots of hexanes. Let's go ahead and number it. So here we are. We've got 1, 2, 3, 4, 5, 6, or we could do 1, 2, 3, 4, 5, 6. These 2 substituents are not the same. So one of those is right and one of those is wrong. Well, which one is it? Well, now that it's a tie in either direction, to get to the substituent the fastest, the 3 position would get me my first substituent. They're not the same substituent, so I need to go in the direction that gets me to the substituent that comes first in the alphabet. And so I have methyl versus chloro. And so in that case, the blue numbering scheme was correct. So I've got a hexane, and it's got a 3 chloro, 4 methyl hexane. Okay, so now we're moving on to a little bit more complicated of a structure. Might have to figure out a little bit more which one of these is the longest chain. 1, 2, 3, 4, 5, 6 that way. 1, 2, 3, 4, 5, 6 that way. Oh, 1, 2, 3, 4, 5, 6 that way. And 1, 2, 3, 4, 5, 6 that way. 1, 2, 3, 4, 5, 6 that way. Okay, well, which one is it? There's lots of different 6 carbon chains, and they're not all right. So when you've got multiple paths to choose for the 6 carbon chain, I'm going to go ahead and go 1, 2, 3, 1, 2, 3, 4, 5, 6. And I've got another one. 1, 2, 3, 4, 5, 6. Those are the only unique ones because you could see that if I started here or started here, 1, 2, 3, 4, 5, 6, those are the same paths as one of the other ones. So we only need to consider these the green path and the yellow path. Which one is correct? Well, the correct one is the one that has the most number of substituents. And it looks like they both have 3 substituents. No, excuse me. The green path has 1, 2 substituents, and the yellow path has 1, 2, 3 substituents. So that means that the correct path is the yellow path because we always choose the path that has the most individual substituents. So now that I've done that, now I can move on to numbering. And numbering happens the same way it did before. We'll number in the direction that gets us to a substituent the fastest. So there's my 6 carbon chain in the correct order. So it's a hexane. It looks like I have 1, 2 ethyl groups and a methyl group. So if I wanted to put this together, I would call it 3, 4 diethyl, 2 methyl hexane. Okay, got that one done. All right, let's do the next one. All right, here's our last one. It's a little bit of a complicated situation, so we're going to have to figure out the longest chain. 1, 2, 3, 4, 5, 6, 7. Okay, we got out of hexane. So let's try a different path though. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So the yellow path is automatically not the correct path because there's something longer than 7. So we've got 8 that way. So let's try another one. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. So again, the green path is no longer the correct path because we have a path that has 9. Is there a path that's longer than 9? It doesn't seem like there's going to be. And so this is the only possible path that would be correct. It's 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, which way do I number from? Again, I still number in the direction that gets me to a substituent the fastest. If I went this way, it would be 1, 2, 3, 4. If I go this way, it's 1, 2, 3. So it looks like the red path would be correct. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what kind of substituents do I have? Methyl, 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 and then whatever this guy is, we'll have to figure that out in a second. So I have a trimethyl, and so that's 3, 4, 6 trimethyl. And then what is this guy in green here? How many carbons does it have? It has 1, 2, 3 carbons. And at the 1 position, there's a methyl group. So that means that at the 5 position, I have a 1 methyl propyl. So let's put it all together now. So I've got I've got to figure out which one of these things that I write first. So is it trimethyl or is it methyl propyl? Well, it's going to be alphabetically. But remember, outside of a parentheses, the T does not count in the alphabetizing. What counts in the alphabetizing is the M. So I'm starting with methyl. So alphabetically, I'm comparing methyl to methyl propyl, and methyl will become before methyl propyl alphabetically. And so now I know what comes first. So it's 3, 4, 6 trimethyl, 5, 1 methyl propyl, non-ane. Okay, that's the whole thing. We've named all of these compounds And so we're done. Okay.